Right, so probability, let's start. Let's consider this lecture as a summary of everything. I think the best way for me to start this chapter is by telling you there are two types of probability. Where the first one, it doesn't touch, and the second probability where it touch over here. This is what we call mutually exclusive, and this is not mutually exclusive. As you can see, this one, they never touch each other. So you can kind of say in your English essay that our feelings are mutually exclusive. That means you are in the head-head relationship territory. Or you can say this is your ignore zone, this is your friend zone. So choose which one is worse for you. Have you ever been ignored in your life? I can tell you. We can talk about that experience later. Leave in the comment. You don't have to start the drama in the class now. Okay, so for this one here, there is an intersection. I can say since there's an intersection, I need to minus the overlap. This one here, there's no overlap, so I can kind of say PA intersect B equals to 0. This one, it has value. This one, no value. Alright, for not mutually exclusive, there are two types of graph. There are two types of situation. One is when we call it independent. Another one is what we call not independent. Or dependent, just depends on the language you want to use. Independent when it is PA intersect B equals to PA times PB. Okay, this P stands for probability. I might need to zoom out a bit. This one here simply means PA intersect B is not you can see not equals to PA times PB. So technically what we are saying is that when it's just a characteristic, we are naming them. When I times this, I got this, we call it independent. When I times this, it's not equals to this, then we call it dependent. It's just a matter of characteristics. Okay, so what is independent? When PA intersect B equals to PA times PB. When is it dependent? When PA intersect B is not equals to PA times PB. So sometimes life is not as it seems. Like if I give you questions like this, can you see it? If I give you this kind of questions, you can read over here. It says that Aziz, it's about Aziz and Bong. Yeah, it's a weird name. And if you read this line, if they attempt to solve the puzzle without consulting each other, you see this line? If they attempt to solve the question without consulting each other, then it means it's what? It's independent. Alright, so the value of PA intersect B over here is 0.65 times 0.6. Okay? It depends on the questions. But if they didn't say, if I give you an example something like this, one moment. Sorry, this is going to take a while. If you read this question number 18, this question, we were told that the husband is 0.7, the wife is 0.5, and then probability husband and given wife is 14/15. Given is another topic which I haven't teach yet in this lecture. Okay, does it say it's independent or does it say it's dependent? There are nothing. You're given in this context of questions, there are no clues it's dependent or independent. My advice, if you ever encounter such a questions, assume it is dependent. If it doesn't say anything, assume it is dependent. Because most of the time, if you assume it's independent, you will get it wrong. Okay, let's say for this moment here, you say, oh, it doesn't say anything. I know this is my husband. I know this is my wife. So this is normally what will happen. PA intersect B is going to be the husband times wife, 0.7 times 0.5. When do you do this? When it is independent. But since the question doesn't state it's independent, you cannot do these steps. If you do these steps, well, particularly for this question as well, you're just going to get it wrong. And I've seen this a lot among students. So be careful, okay? We're going to try this question later if you have enough time. So be careful with it. You need to memorize this formula. If you don't memorize them, I cannot help you. When is it independent? When PA intersect B equals to PA times PB. When is it dependent? When PA intersect B equals to PA times PB. Because sometimes you will be forced to ask these questions. Okay, we try the questions later if you have enough time. All right, as you have known, I'm a highly advocate of hashtag technique. Because personally for me, it makes life a lot simpler. Okay, so let's try examples. Just a very small example just to get things started. Hashtag technique is when there's the two cases A and B. Alright, I'm going to use the same example again for a while. Let's say I got myself 120 students. Okay, this is just a summary, so I'm going to be fast. Something happened on the screen? And I was told there are 12 members of hockey. And there are 25. Sorry, this is a bit too easy. This is not the example I want. Say 120 over there. Bio, there are 60 students. And physics, there are 50 students. And studying both is 20. So for this one, I can say this is my A, this is my B, this is my total, this is my, where you can say A intersect B. Right, I can say it that way. So for you to start the hashtag technique, firstly draw the hashtag. And right now write things down. This is bio, not bio, or simply if you prefer A prime. And then this one is physics, not physics, or simply maybe you prefer B and B prime. Maybe you prefer it that way. And we know here we are given 120, so in the terms of fractions, probability, 120 over 120, which is equals to 1. You write it down over here. Okay, you need to know, just a summary. This is what I prefer to call it the data, this box. Data or data depends on which continent are you from. And this outline outside here, this is what I prefer to call it as the total. So the total of bio is 60. Where do I write this down? Down here. 60 over 120. The total of physics, 50. I write it down over here. 50 over 120. And I know this one both A intersect B. I write it down over here, biophysics. 20/120. And then we can fill in the blanks, which is not that difficult. 60/120. This is 30/120. This is 40/120. This is 70/120. Just a simple arithmetics. And this one here, 30/120. And from here we can have all sorts of questions which is easy for us to figure out. Such as if I ask you directly for how many people take only bio, which one is only bio? Is it 60? This is bio, right? What's wrong with it if I'm taking just on this one? Because if I'm taking this one, that means I'm plusing this one. If I'm plusing this one, I'm taking bio and physics as well. So if only bio is, it's just this small part, 40/120. Are you okay? So if I'm saying something like neither physics nor bio, that means they're not taking both, neither physics nor bio. So it's over here, 30/120. Are you okay? Now, what about if I ask something such as physics? Okay, let's clarify a few things. Physics and bio, which one? Physics and bio, 20. Okay, all right. Simplify if it's possible. This I'm going to be fast. This one. What about physics or bio? Where is it? Where is physics or bio? Physics or bio is either you can calculate this way. This is bio, this is physics. Or that means you need to plus everything's up. Either you take this whole side. So either you do 60 plus 50. This one is going to be wrong because you overlap this one twice. Okay, this is the situation where you got this situation. Right, where you need to minus the intersection. So either you do 60 plus 50 minus 20, 120, or the other way, which I prefer to do, you take this part, the A part, plus the B part here, and then plus the intersection here. Is it possible over here, sir? Yes, you are right. This is the blue part. You plus these three things. And personally for me, plussing these three small numbers is easier than plussing two numbers minus one small numbers. 20 plus 40 plus 30, then you get the answer straight away. Which give you 90/120. Okay? And this question can come out over and over again. I'll show you different examples later. Alright, in the case of what I've shown you briefly just now about Aziz and Bong, this one here, let's write down Aziz is a 0.65, Bong is 0.6. Okay, now I know why Aziz and Bong, because A and B. Maybe the question provider did think of that. And we were told over here that solve without consulting each other. So simply, Aziz not be able to solve, Bong not be able to solve. Okay, I should have drawn the hashtag first to avoid confusion. Aziz 0.65, Bong 0.6. I got some people asking me this question. Sir, this is in decimals, they are not in fraction. Should I divide by something to get a fraction? Well, decimals and fractions, they are kind of the same things on the first place. So you don't have to turn them into fraction. And what about the total? Is it 0.65 plus 0.6? No, it's not. The total of probability will always be equals to 1. Okay, now going back to the things just now, what do we need to find one thing inside for us to solve. How? How are we going to solve this one here? We did mention just now, solve without consulting each other. What does it mean? It's independent. So, independent, what does it mean? PA intersect B equals to PA times PB. Right, so 0.6 plus times 0.65, can you please calculate that? 0.39. Let's put it over here. It's 0.39. And then from there you can fill up the rest. Are you okay? If you're just filling up the rest, over here will be 0.21, 0.3, 0.35, 0.2, sorry, 6, 0.04. And then from here it's quite clear for you to solve them. The questions can go further, such as correct by both of them. Correct by both is which one? Did I calculate wrongly somewhere? Oh, 0.4 here. Sorry. Did this one wrong, right? So going here 0.14. I wish. That's going to take some time. But I was careful enough, sorry. If correct by both is which one? Correct by both? The intersect Aziz and Bong. 0.39. Now, if I ask you only one of them correct? Only one correct? Either Aziz correct, either Aziz. It's quite hard to say, you know. Aziz is correct, Bong is wrong, or Bong is correct, Aziz is wrong. So you need to add them up. So I can write it down something like this. Intersect B prime. Okay. Oh, sorry. I don't think you saw that. Should I write down directly 0.47 without doing this thing in exams first? Well, I would recommend you to write them down, because if your answer is wrong, at least you got 1 mark for your working. If you accidentally calculate wrong like me, and you say, sir, we won't calculate wrong like you, good you. Okay. No comment on that one. Okay, can we move on? The examples that I really like for this, I think I've shown the class several times, and I just include it in the lectures. It's the past year questions, which is quite naughty. It's not that hot levels. Some of you have seen, I've shown these examples. But I really like it. because it does test your understanding. Oh yes, this one is A bar, which can also be translated into A prime. Okay, if you see this question, is A intersect B is 1 over 4. This is quite an unusual questions. A prime is 2 over 3. And what about here? The total is 1. And this is weird. This is all you have. And where should I write down this one? Where is A union B in this case? A union B, the data is supposed to be in this region, right? Is A union B. The data will be this one, and this one. And we know that the total number of data is 3 over 4. And we can calculate further. If it is 2 over 3, this is 1 over 3. 1 over 4 plus what I got 1 over 3? 1 over 12 if I'm not mistaken. 1 over 3 minus 1 over 4? 1 over 12. And I know this total number is give 3 over 4. So 3 over 4 minus 1 over 4 minus 1 over 12. 5 over 12 if I'm not mistaken. 3 over 4 minus 1 over 4 minus 1 over 12. 5 over 12. This one here, if I'm not mistaken, is 2 over 3. 1 over 3. This one? 5 over 12. 1 over 4. And we got that. This is a very nice way of doing things. Okay, move along from hashtag. Are you okay? This is just a matter of you know where to put your numbers in. Okay, other things you need to know about probability is a given case. It may come out in a multiple way given if known that sort of this sort of troubles. And if I write down to you PA and this one straight line, it's not modulus, and someone said, well, one modulus or straight line, sir. How we read it is as PA given B. What does it mean? It means PA intersect B over PB. This is how we write things down. How we read it as PA given B. What does it mean? It's just this formula. You can open it up. I've seen people who say, sir, I don't understand this. No, it just simply means this. And some people mistaken, oh, this is the union. No. It means PA intersect B over PB. Simply, if you see this, write in this way. In exams, they can give you all sort of stuff. They can write to you such as A intersect A given B, or A if B, or it's a known that, it's all right. Knowing that, okay, maybe I need to write down a bit properly. A knowing that B, is my camera lagging? If I give you something in this thing, it just means that or the exam can be a bit cruel for you. It can say something like this: given B then A, or if B then A, or knowing that B, then A. It simply means the same thing as well. This is what you used to call yourself an active sentence and passive sentence. Which I think that the most cruelest of all questions. If I give you sort of the married couple just now, okay, it says here, okay, the computer's okay already. Husband will pass his test given his wife pass. What does it mean? Husband pass given his wife pass. It means husband husband given wife. Is 14/15. So I can open it up, this thing, I can open it up, becomes husband intersect wife over wife. And this thing is 14/15. Okay, we solve this a bit later. I think the most cruelest of all questions I've seen is, you can say this, the last one. If a refrigerator is found defective, find probability it was produced at plant A, plant B, plant C. So this one here, if we have a look on the first one, the A one, it says, you see here, if defective, then plant A. Can you see here? If defective, then find the probability it was produced at plant A. So for these particular questions, it's going to be the probability of A given defective. So be very careful in exams. They might hide the if over here. Okay, such questions come out, you are so dead if you're not careful. Okay, the one that I've seen a lot of people making these mistakes, you know who you are, is reading this line, overweight knowing that. You see the word knowing that? So this one is what? The one that knows, please, that they have encountered this, keep quiet for one moment. This is what? Overweight given. If you say overweight given illness, you're wrong because they have this word not here. So it's overweight given no illness. So be careful in exams. They might be very, very devilish, such as this. Okay, going back just now. There are two facts that you need to be careful though. About given. If, note one, if A and B are mutually exclusive, then P A intersect B is 0. So the given is also 0. If A and B are independent, then PA given B is equals to PA. I'll show you this one. So PA given B, I can also rewrite it as PA intersect B over PB. And what do I know about independent? What do I know about independent? PA times PB, right? Which I've saying that to you many, many times. Over PB. And I can cancel things off here. So which only leave me PA. So this is what we start with just now. This is our premise. This only happens for independent cases. I've seen such questions come out in a show type questions. So you do need to know this one. So be careful with it. Some of you still copying. So let's go back a bit with the husband and wife just now. because that's normal exams questions. Okay, can we continue? Husband and wife driving test just now. Let's get the hashtag right. So I know that the husband pass is 0.7, the wife pass 0.5, and given husband given his wife pass is 14/15. Okay, so I can draw the hashtag husband, not husband, wife fail, husband is 0.7, wife is 0.5, the total, oh, for a moment I thought it was due on. Okay, let's go a moment. Okay, no, we do not have this intersect, right? How do we find this intersect? Well, through what we have said just now, husband given wife, we have mentioned just now is this far. Okay, and do I know about wife? Yes, I know wife is 0.5, we know over here, so I can substitute. So what do I do with this? I cross multiply over here. So I get myself 7/15. So over here 7/15, and then you can fill up the rest. Okay? Can I leave this to you on your own? I leave this to you on your own. Yeah, am I too fast? You okay? Are you okay? Can we continue? All right. If I have enough time, please do. Okay, another type of question is the tree type questions, where in exams, don't worry, they will normally say to you, use tree. Do a tree diagram for this. Normally things happen when A then B. It's not A and B, it's A then B. B need to happen only after A. The tree diagram going to look something like this. A, not A, B, not B, B, not B. The tree diagram can appear in many forms. Can I have a look? Okay, let's have a look on these questions. It says here, Harry travels to work either by route A or route B. Probability that he chooses route A is 1/4. Probability he's late for work, route A is 2/3, and he's late for work. And if he chooses route B, his late is 1/3. Okay, so let's give it a try. So probability, firstly, he chooses route A is 1/4. Okay, we can change here A, and let's give it a big. So either he takes route A or route B, and then probability of choosing route A is 1/4. We do not have probability for route B, but we can give it a guess. How much? 3/4. How do you know? Simply 1/4. 1 minus 1/4. And continue on. He said if he choose this one and he's late for work, if he choose route A is 2/3. So that means the not late is 1/3, simply. Now if he choose route B and he's late for work, B late is 1/3. And the not late is 2/3. And then the question can ask you something like this. A, find the probability that he's late for work. If we look straight away for this question, the late is only here and here, right? Can I just simply do 2/3 plus 1/3? You're going to get it wrong. That means it's absolutely late. You need to choose the whole branch together that comes together with it. It means this whole branch. And then this whole branch as well. You need to come, like I mentioned before, A then B. Now, how do I connect these two? Plus or times? Y times? Kim's case, very good. This one, times, now probability that he's late. These two cases, you need to plus, because it's different cases. You guys okay? And that one simply is 5/12. Sorry, I'm skipping steps a bit. Now, let me ask you a quick question, extra a bit. Now, what about probability that he's not late? How do you solve this one? You take this branch, and minus it, and plus it. You can do it that way, which is not wrong. You can do this branch, you can do this branch plus, or simply, I know this is late, the counter of it will be not late. So simply 1 minus. Wow. That's a different way of thinking. Now, what about if I ask you finally, given he's not late for work, oh damn. Given he's not late, what's the probability he choose route B? How do we do this? Well, firstly, you need to decode this given case first. How do I write things down? The correct answer will be the probability of route B is not late. Given is paired with this one. And then, of course, you need to decode this one. P, B, oopsie, intersect, not late, over P, not late. Are you okay? And do we know P not late? We know we have calculated here from the second part just now. 7/12. What about PB not late? Where is PB not late? It's this branch. Okay, this is the PB not late. So how do I calculate this one? 3/4 times 2/3. And carefully press that into your calculator, you should get your answers. 7/12. Sorry, 6/7. You okay? Alright, a little bit extra. This is okay, something a little bit extra for you. This is no longer in our syllabus, but I really do like it. De Morgan's theorem, I really do like it. Is if I give you something like this, PA intersect B, and then there's a prime here. The prime can act like a negative. I can multiply them inside. So I get what? What's the opposite of A? A prime. What's the opposite of intersect? Union. What's the opposite of B? B prime. At the same time as well, I can factorize my prime out. I can times them in, I can factorize it out. So basically, what's the factorize of A? What's the opposite of A? A. What's the opposite of union? Intersect. Opposite of B prime? B. But I got this prime outside. Okay? Such a question that I like. I'll take an easy one. If I give you this one, PA 0.25, PB 0.5, and PA intersect B 0.125. So if I were to draw the hashtag A prime, B prime, A 0.25, B 0.5, here is 1, here is 0.125. My goodness, why so small? Rushing. 0.5, 0.75, 0.875. Oh, this is wrong. Sorry. 0.125. This one here, 0.375. And this one here, I guess it's the same, 0.375. For this particular question, we need to find B, PA union B prime. And how do I find this PA union B prime? Well, you know yourself that PA is what? PA prime. I can also rewrite it as PA. So this one I can also rewrite it as 1 minus PA union B. And where is PA union B? Where is A union B? These three things, right? So you need to plus this thing and 1 minus those. You get the answers. I'm not saying it's wrong, but when I saw this question, instantly in my head, I saw this thing. Oh, De Morgan's. I can simply multiply them in. So I get myself opposite of A prime. Opposite of union, intersect. Opposite of B prime. And I can see this answer instantly where? Boom. 0.375. It's a nice little trick. Will you be needing this in proof questions? If I'm not mistaken, in the old syllabus, maybe. In the new syllabus, maybe not. I'm not sure. Okay, I haven't seen those questions yet. Okay, we have a bit of small time before your next lecturer come. This is what I call the growing tree. I don't think I can do justice for these questions. It's for these questions, I see you have seen this in the tutorial before. The second one, we're going to do the second one. So basically, there are 3 boxes, and each box they have 2 cards, blue and green. Okay, for the part B, read here. These cards are inserted into the original box, so we have those situations. A card is drawn randomly from box P, inserted into box Q. Then a card is drawn from box Q, then inserted into box R. Okay, what it means is something like this. Okay, do take notes. I have 3 chains but 2 branches. So 3 events, you can call it. So I can say here is P. P give me blue or green. Then Q give me another blue or green. Then, sorry, R. R give me another blue, green, sorry. Running out of time. Blue, green. Okay, originally, let's just do the first branch. Okay, I'm not going to do all of them. Originally, is over here is a 4/7, 3/9, 6/9, 2/6, and 4/6. Oh my goodness, this is quite tough when you're under pressure. Okay, I'm just going to do the first branch. Okay, so as you have read just now, cut is drawn from box P inserted into box Q. Cut is drawn from box Q inserted into box R. Let's say we start with this branch. I take the blue and I insert it into my second box. This is my first box. This is my second box. This is my third box. This is, the third box in a different path. So I take my blue, I insert it into here. At this moment here, this blue increase. Whoa. Okay, back. This blue increase becomes 4. The totals becomes 10. This one, the green remain the same. Why the green remain the same? I'm taking the blue, but the total becomes 10. Okay. Now I'm taking this blue. I'm putting it into this box. I got myself 3/7. This one, 4/7. But what about this one? 3/7? No, it's wrong because this time I'm taking the green. So this time I'm adding to the green. 5/7. This one. However, the total will increase. Okay, if I'm speaking too fast, please slow down the video and watch it again. Okay, you may try it out by your own for the second path. Okay, we have a bit of time. Now, if I ask you a question, give me the one with 2 greens outcomes. Only 2 greens. Which one? Only 2 green. Which branch? Blue, green, green. Or you can see here blue, green, green. Or green, green, blue. Yes, one more. Green, blue, green. So this one you need to kind of think about it. I think we have one more. Okay, I think that's all. Alright, that's all from me for probability. About P and C, which I did not cover in this lecture. Permutation, combination, probability. Basically, take the case divided by all cases. And you are done. Alright. Case divided by all cases. Okay, that's all for me about probability summaries. Thank you for listening. Please comment, share, like, and subscribe. And give me one smile, big face before your holiday. Okay, happy holidays.